have their you're all welcome to have your camera on or off as you see fit. Welcome game. So maybe what I will do is just going through my screen here, invite everyone to offer a brief introduction as to your team and any background you may have with vision processing, and most importantly, what you would hope to gain from our discussion this evening or in the next little while, because that might help us to organize the best learning opportunity. I'll start with Ian Phillips, with whom I was just speaking.
Hello. I'm trying. It's trying to find our number.
8765, I would suspect.
Yeah, sorry.
That's okay.
One thing I'm not up to speed on. Yeah, so my experience has been primarily the entertainment industry. Essentially everything from flying machinery, pulling hydraulics, pneumatics, electrics, and basically anything involved that has people around it, essentially. Kind of do the opposite of what industry does. Industry puts up safeguards to keep people away. We put them on it, in it, under it, over it, and through it. So that's been kind of my background. And then, as I was saying earlier, vision-wise, it's more most of the products that existed in the past 20 years that I've been doing this either couldn't handle the atmosphere and the other fog and other stuff we put into the room for special effects. So really, I kind of eliminated that whole possibility of using vision cameras, anything like that. But with the newer stuff, with IR and the newer video processing gear that's out there, we can actually use a lot of that stuff now. But again, it's mostly IR based. So as I said earlier, I'm very curious to hear what's possibly in store here.
Thank you so much, Ian. Great to meet you. We'll go on to Connor.
Hello, I'm Connor. I'm here for Team 7475. I'm their programming mentor. So I was on the team when I was in high school, and I came back to help them with some of their programming problems they've been having. So I started messing with vision processing when I was on the team originally, but I never got to see it finished because I had graduated, unfortunately. So I'm just kind of hoping to see what sort of the basis is for putting that on a first system and how to go along with that. So looking forward to seeing how this goes.
Great, thank you so much. And we will move on to Abel.
Hi, sorry, I'm just getting home, trying to fit in dinner and get everything, pay attention. All right, I'm the mentor for 7022, and yeah, we don't really have much experience at all with vision processing, so we just bought a Limelight at the end of last year, and we're hoping to figure it out this year so we can try and add it into our robot this year. So just kind of, I have zero experience with vision, so
thank you so much.
Hopefully to learn a bit about
that. So we move on then to David.
Hello, I'm Dave Tops. I'm mentor with build mentor with 4152 in Huntsville. Although I'm not really directly into the programming, my son Samuel, who's on the call as well and is also a mentor, has been quite into it. And so he often bounces ideas off me. We talk things through quite a bit. So I'm still pretty aware of a lot of what's going on with the vision and seeing a lot of the developments in that. So just interested to see what people are coming up with and what I can learn. So.
Excellent. Thank you so much, David. We'll go to Eric.
Yeah, I'm a lead mentor for 4917 and a software mentor. We have been using Vision since 2015, initially with a webcam, now with a Limelight. Good purchase, by the way. It's makes it a lot easier. I'm mostly here to probably because we're going to be touching on the new Vision stuff, and I'm kind of curious to see what First has to how it has lined things up to be able to use that. So that's definitely looking like an interesting topic for us.
So with respect to that comment, I just put a little comment in the chat, just curious, as you are correct. The topic of this evening I have chosen as my best guest for what might help the teams is April tags, as that's a very new component this season. John.
Yes, I'm a mentor for 7690. We have never been able to raise enough money to buy a Limelight. So back in 2020, we actually worked with a Raspberry Pi 3B at that time. Students got it to recognize the reflective tape. We just never got it into our system. So it was a project we sort of completed on the side, but we never got it in, embedded into our robot code. Since then, we haven't done anything else with any vision. This is the first year we're playing since then. So I've sort of tasked our programming people to look at April tags and see if we can use the existing camera that we had and the Raspberry Pi to see if we can get that to work this year.
Great. Thank you very much, John. And Samuel.
Yeah, he's just trying to get reception again. He was getting far away here.
I believe, Samuel, you may be muted. Or at least your microphone may be not working, as we're not hearing you. At least I'm not.
Does that work?
Yes.
Yeah. Sometimes my headphones sometimes work, sometimes not. Yeah, so we got into vision processing in 2020 when we bought a Limelight. Used it in 2020 and 2022. We used it in conjunction with a turreted shooter, so we could aim at the target from various angles. And this year we've been playing around with photon vision on the Limelights, so a different software. And we've been messing around with the April tags and having a good experience with it. So yeah.
Excellent. That's really great. Thank you, Samuel. How about Al?
Hi, I'm Al Douglas with 4903 in Windsor. I'm a strategy mentor, but I have my hands on a lot of different things. I teach robotics at St. Clair College as well. We used vision for the first time in 2020 to target and shoot. We did not use it in 2022 as we lost a lot of our programming capability and didn't have the ability to integrate it. But we are hoping to get back into it this year to be able to drive to position and things like that. I've done a little bit of checking on the April tags and watching some videos and stuff like that, but no experimentation yet.
Great. And that brings us to Antoine.
Hi, good evening, guys. Yeah, so my name's Antoine. I'm from 2609, and we really only used a Limelight last year. They tried back in 2020, the students, and we had a good programming mentor. So really only got Limelight functional, I would say, last year, and we lost that mentor this year. So we're kind of back to basics on vision this year. Although I do know what April tags are, and I've done a tiny bit of research on it, and have a small open CV program working in Python just to read them. So I've got a decent understanding of what it is.
Nice. So that's great. We have a varied kind of experience level here. Based on what everyone has said, I was going to do a quick review of a presentation made at the Swapposium last year, outlining a few elements of the typical vision system leading up to this year. And this is a year where we're going to have two new things. One, a different type of retroreflective tape, as they've run out of stock on the traditional one, and they're phasing it out. And then two, they will be implementing April tags on the field for the first time. So I'll just give a quick overview, and I'm not going to go into too much detail, but if anyone is interested, I could send you my materials that I've used before on the Raspberry Pi to make it automatically boot up into a program and to execute certain, for example, we had it programmed to boot up into a Python script and then execute that continuously, sending over network tables any images that it may find through its OpenCV implementation. So that's one thing that I'll just overview, and I'll be able to share that by email later. And then the next part of our discussion this evening, we can go into April tags. What are they? And they're actually quite accessible, I found, as it didn't take all that long to implement April tags in Python using my existing Python that I had already set up with OpenCV. And so the big question may be as to, well, how are we going to process the images? I've heard two approaches used by teams, and maybe it would be great to hear from you at any point if you've had experience with Vision in the past, or if you're thinking of one or the other solution as to, for example, placing the code on your Roborio, or Roborio as everyone else says, and the other option being the co-processor, such as a Raspberry Pi. So I'd love to hear your experience with there. Some of you have already implemented Vision on your teams in previous years. So with your permission, I will just share part of a presentation that we did last year at Swapposium and then switch over to discussing April tags. The first presentation, just giving an overview of what we had done with Vision typically in teams up until that point. So as you see, this was from the Swapposium. And in that discussion, we took a little more time to talk about the Linux operating system, as it's the operating system used by the Raspberry Pi. And you need to know a few things if you're going to go about it without just downloading the image that is available from the WPI lib. Then we went through an introduction of the Raspberry Pi. It is worth noting, maybe we'll have this in the discussion later, one of the challenges is obtaining a Raspberry Pi currently, as they're in rather short supply. Just fast forwarding, it is a good idea for you to look into the Linux operating system to have some basic knowledge of it if you're going to be using a Raspberry Pi, just understand what's happening. Also, Linux operating system is native on the Roborio, and you will find using command lines and secure shell commands, you can get some extra control over your Roborio and find ways to take advantage of its computing power and install different programs on it. Okay, so not to go into too much detail about that, but Linux has changed the world, and it's in pretty much every device, your car, your watch, your Mars rovers, and the like. And it's made quite an impact in FIRST as well with the software that we use. And it's good for you to know the Linux operating system file system. And it's quite distinct from Windows, but if you have ever used Unix in the past, it would be familiar to a Unix user or even a Mac user. Your Mac directories are similar to the Linux directories. Having some very basic commands, just flashing through these. This is not a session on Linux, but learning on the many online tutorials how to use commands to manipulate files, view their contents, and install them in certain directories goes a long way to helping you set up a Raspberry Pi for a Vision system. Here's what I really wanted to focus on, just the big overall picture. Here's the system that my team used, and we never got to use this too much in practice in the competitions as we were trying to work on other issues with our robots, but in the classroom, we did this a lot. And the system consisted of, first of all, an Arduino that had a little script that would drive the LED ring that we had and produce bright green light. That was hooked in through the power source of our robot. And this Arduino is quite passive. It was just running a very simple script to send green light signals to our LED ring, which we soldered ourselves and connected up very nicely to our Arduino Uno. So that was one part of it. This LED ring then was aligned around our camera and shone the light in the direction of the camera with the hope that it would find a retroreflective target, which would send that green light straight back to the camera and enable a vision target to be processed. Now, the processing of the vision target took place on a Raspberry Pi hooked up to one of these webcams. You have to set it up to recognize, make sure that it's recognizing that webcam and see if it can process images off of the image stream coming in. So you'll need a little bit of knowledge of OpenCV and different scripts like that. I can share what we had. I'm sure lots of other teams have even much more sophisticated material to share in that regard. Then the Raspberry Pi, the point of the coprocessor is not to slow down the central computer of the robot, the RoboRio, because that would cause issues with time or timeliness of your robot in performing certain tasks. So the processing taking off board, we reduce an image down to some data, such as the X and Y values of any vision targets that may have been found, in addition to their width and height and how many sides they may have. And that is sent over a Ethernet connection on the robot as a set of numbers using the functionality of our programming system, the network tables. And so now you're just sending a little bit of data across every second. And instead of trying to send entire vision streams across. Now, there are different teams that have done different things. By reducing the size of the images, it is possible to take the image right onto the RoboRio. You trade off the accuracy and resolution of the images, but then you have the advantage of not having to worry about network lag. Network lag can be a serious issue unless you carefully program your whole system to not have delays, possibly due to network sort of lagging behind the other program, which is running the robot at the time. So those are the trade-offs. It would be great to hear from any teams as to what solutions they adopted in the previous seasons to accurately and effectively implement vision into their robotics team's solution. Okay, so the Raspberry Pi system here. We have an SD card as a hard drive, therefore you can use whichever size of hard drive you like. We are using 16 gigabyte hard drives, which had way more than enough space to handle what we were doing. This Raspberry Pi 4, we can tell it's a Raspberry Pi 4 because it has these micro HDMI ports. It has something like 4 gigabytes of RAM, or the one we had 4 gigabytes of RAM. And it's considerably faster than the earlier iterations of the Raspberry Pi. You probably have to use a 3 or a 4 to have an effective co-processing solution. I'm not sure about the Raspberry Pi 1 and 2 as they're getting a little old now. One thing that is possible, if you don't have a Raspberry Pi available, you can install one in VirtualBox, and that's something like VMware. It's a free computer emulator solution, and you can etch an image onto a file on your computer and load it up just like it's putting an SD card into a Raspberry Pi. So you can emulate your Raspberry Pi right on your system, and therefore you don't have to wait for them to install it on the robot and just test it working out. It is possible to also connect it to a webcam through your own computer system into the virtual Raspberry Pi. And so that's a way for you to develop in parallel while the robotics construction team or the fabrication and electronics and such, all of those teams are building the robot. Okay, and now regardless as to whether you're going to be processing retroreflective tape targets or April tags. Here we have OpenCV as a very handy library that's readily usable with Python and probably some others. I'm not sure if it's C and Java. I've only used it with Python. There are tutorials online that show you how to get basic things done. And it's a good idea for you to do some tutorials on OpenCV, take some static images and see what can be processed out of them using various OpenCV scripts that you can write in Python or find as examples on the internet. And that will help you to get your vision processing program going. Here's the kind of the structure of what we did on the Raspberry Pi. The Python script, basically it initializes a connection with the camera with a few commands, and then it initializes a connection with network tables with a few commands. And then it repeats continuously on into infinity, which is as long as the robot is on. It takes an image stream in through the camera, analyzes the shapes, and using parameters that are developed in OpenCV and possibly with the help of a program like Grip or something like that, it determines if any of the shapes meet the criteria. And if so, we report useful information to network tables such as the height, width, and X and Y positions, and etc. And therefore, from this last line here, you're sending over the network only small amounts of information, not entire photos. Every second, many photos kind of clogging up the bandwidth of the computers involved. So here's a picture of a kind of a rigged up board that my students made in their class. So it's part of a project done by some IB students at my school. Their project was to make a vision system. This is one of our first tests. It's not actually all ready to go yet. We are just seeing how the Raspberry Pi connected to our LED ring. Carefully soldering the LED ring is a really great idea, and using things like shrink wrap and carefully organized cables made all the difference for us. And so that's one of the tests that they did. It just shows our 2 sample webcams. These Microsoft webcams are a little bit finicky. It might be good for you to have a 3D printed or similar bracket to keep them pointing in a very particular direction. You can also mount them onto servos and have them point in different directions depending on your needs from year to year. So those are the vision system components. And here's a sort of a photo of one of the students identifying the yellow ball in the 2020 game. He also found hexagons from our vision targets. We had a hexagonal set of retroreflective tape, and his little script was able to identify either the balls or the hexagonal, or is it octagonal? One of those vision targets in the 2020 game. And here he is with a sort of a calibration program used to determine which colors to sort for in the OpenCV settings. So that was a really handy program. You can find numerous such programs on the internet. And he made some little sliders and was able to filter out particular parameters to look for the yellow only in his camera feed. Okay, and what you need to do to sort of work in a completely custom solution is to install some startup scripts. Here is a very particular startup script that would work in this particular directory in the Raspberry Pi, and with a in the home directory under the Pi subdirectory, you can put this video processor.py file, and this script will start it up automatically upon startup. And there are some of the commands you would need. I'm not going to go through them in detail. You can save them for reference later, and I'd be very happy to answer any questions later through some further emails and that would be shared with the community. So I guess I just wanted to introduce this sort of thing. This is much more than we could accomplish in an hour call. It's simply just to let everyone know the different components that have been used and that many of you may have already used to get a basic vision system installed and working. This particular presentation was focused on the retroreflective tape vision system, and it could also be used with April tags. We just have to make some adjustments to the Python program running on the Raspberry Pi and or the RoboRead. So I'm just going to stop there for a moment, see if there are any questions before we continue on to the next part of our presentation. Good. So yeah, we'll definitely send some links to any of the relevant files here. So based on the feedback here, many of the mentors here on the call have not experimented with April tags yet, and there are a few who have. And so if you have, I'd be very happy if you would also chime in and offer any insights as to what you may have seen in your experimentation with April tags. So here we go with the second part of our presentation. So this is our robot vision April tags. We already had introductions in the first part. I just threw in that other sort of presentation since we still may need to use retroreflective tape this season. That previous presentation is still valid in a way. Here is some text from the updates in the blogs. We don't have to read through the whole thing. The idea is that we're out of vision tape, and so they're using a new 3M973-10 white retroreflective tape in 2-inch width for the 2023 field. And so they're also recommending that everyone waits for the kit of parts. We're anticipating being able to provide this tape. So just a little excerpt from a blog many of you may have already seen. Also, that there are some parts of WPI lib that are now suited to connecting with April tags. I'm not going to talk about that this evening, as I don't have a connection to the beta testing WPI lib package. If any of you has that connection, it would be great to hear any of the thoughts you may have about accessing April tag information from within inside WPI lib. I'm just going to go over the very basics of what April tags are and how a basic Python script may be used to process them. Okay, so there is a little note about beta testing, essentially that you may sign up for beta testing. It may be a little late in the season as that started earlier in October. And so you may be able to get access to play with April tags through the code base in this manner. So now we come to April tags. You will recognize them as mini QR code-like shapes. And there's a bunch of April tags in an image. And there are a few different formats for April tags. Not all April tags are the same. So you must be aware of which format that you're using in processing on the field when you write any software related to the April tags. Oops. It seems to have skipped a slide. I don't know why that is. It looks like it was skipping this slide, and I'm not sure why. This slide is simply showing different types of April tag formats. It's worth noting that the format that we'll use in FRC is the tag 36H11 format. As you see, it has a white border and then a black border. And then within that, we have some other patterns of white and black squares, as opposed to some of the other standards that you see out there that are square and not so square in their shape and configuration. We'll go back to this slideshow and see if that's going to load. I guess not, but we can go right down to making sure that's the right slide. A Python program to process April tags. And there are a few prerequisites if you're going to use Python to do this. And what was required today for me was to install this April tag pip installation package. I already had my OpenCV Python package installed in my particular Python environment, so that was fine for me today. You have to be very careful when installing OpenCV, especially on a Raspberry Pi. It can be a little bit more involved. I think it's getting easier than it was, but a few years ago, it took us about 2 days of class time with a few of my students working really intently to get it installed, as it was a multi-step compilation process. I think it may be possible to install it through pip now on a Raspberry Pi. If anyone has had a different experience, you can let me know, but I think I recall it getting easier a few years ago as opposed to like 4 or 5 years ago. It was really quite something. Okay, so where to run the vision processing program, and maybe in the chat you might comment on any of your team's experiences. Two obvious choices are the coprocessor and the RoboRio. Another one might be to have it processed on your team's laptop. There are teams that have broadcasted the image stream, a reduced resolution image stream, to the laptop, and then found the image characteristics on the laptop and then used network tables again to send them off onto the RoboRio. Several processes available for you. It's interesting, I spoke with a mentor the other day who mentioned that using this Raspberry Pi as a processor and using the RoboRio, one setback of the RoboRio, they used to have their robot pause for about 1 second while it processed an image on the RoboRio. So that could be 1 second of vulnerability in the middle of a busy game. But the trade-off was it worked very nicely as long as they didn't get hit off course in the process of setting up their shot. So they would process a single image, determine the X value of their vision target, and then rotate using a gyro on their robot to get to the exact center of the shot and then take their shot. And there was a latency issue with processing, and they needed a pause. So that's one sort of data point for everyone to consider. It is possible, but you do have to be aware of letting the system have the time to do its calculations. So love to hear of anyone else with experience with Raspberry Pis in this regard as well. Today, I've been in touch with several Raspberry Pi resellers, casually going on to Amazon. The first Raspberry Pi I saw for sale today was over $300. The articles on the Raspberry Pi site itself and other news articles indicate that official resellers are holding the line on selling them for their official prices, which in Canada range around $100 to $130, if I recall correctly, from the CanaKit and PiShop.ca sites. Both of them are sold out at the moment. However, I'm in an email chain with the support group on the PiShop.ca site and hoping to get an indication as to when supplies of these Raspberry Pis might be available. A Facebook Marketplace is also another place that may be used to find Raspberry Pis, and maybe other robotics teams that have surplus, who knows. So one way or another, hopefully your team, if it chooses to go the co-processing route, may be able to find a suitable co-processor. Other teams have used other co-processors. I'm just not so familiar with these, so you may want to look into that if you want to go for an alternative to the Raspberry Pi. Also, an interesting note is that some teams have even used entire laptops on their robots. Instead of a Raspberry Pi, they just set up a full laptop. So what you have to do there is make sure that it's hooked into your networking quite well, and it's probably well secured, because you don't want that laptop being attacked by stray robot appendages in the middle of a match. Okay, so several options there for you. So the general discussion we can have later. What I was going to do now is switch over to the program, a little script here that was developed to sort of illustrate the use of April tags. I'm just going to take a look at a comment in the chat. Yes, Samuel has pointed out that you may track vision tape, that's one thing, but you also may use that same kind of a code or method to track the power cells, cargo, and power cubes. And the picture that was shown of the student developing the system had a single Python script that could both identify tape and the yellow balls on the game field. So here we go with a Python script, April tags. Try that again. Okay, here we are. So here is a little Python script that illustrates April tags. I'll just leaf through the code one by one and make this code available later. The first section here, we're just importing from 3 libraries. So there we are, the April tag library, the OpenCV library, and there's some math that's going on in here. Then we're setting up the file names. Now this is only for an example. Your file name setup would be replaced by extracting images from a vision stream taken from the camera. So there's a good note there. The robot will extract images from a camera stream. Here I'm only having files, as single files processed by this particular script. And here, instead of an output file name, the robot will send, instead of sending it into, for example, results.txt output on the robot, it will go to the network tables. Okay, but given all of that, once you can get your image read, there will be a different command to read the image from the camera stream. And my sample code has such things. This here is just to read a single image off of the hard drive of the computer. There are some other things happening here. It's converted to grayscale. Right here. And there is an interesting option that we're applying. The tag 36H11 April tags. So we need to remember that. And the first few lines of code here, it gets a set of results from its detector using methods that come with the April tags library, and it finds a certain number of April tags. So the next part of this program here, we have some mathematics functions. And you may want to get some of your grade 11 and 12 mathematics students to do a little bit of vectors work. This particular program uses a vector magnitude and a cross product, which is basically regardless as to the angle at which the April tag is found in the image, it's going to find its area and get an estimate as to how far away it is, knowing from the guidance that it's something like 6 or 8 inches wide. This set of mathematical functions would enable you to find how far away it is. And these can be custom developed, or you can use existing Python cross product and vector calculations. The essence is we're calculating the area of the square, which is the April tag, even if it's at an oblique angle in the camera feed. So for more information of that, I'd be very happy to speak about that offline. It's not really within the scope of this overview that we're doing on this evening's discussion. And now this final part here, we set our target count at 0, and that is going to allow us to display one by one each target as it is found. We find the 4 corners of any of the targets that are found. There are the XY coordinates in the camera image, A, B, C, and D, just like a square in a geometry problem. And we're printing these just for reference and converting them to 3-dimensional vectors so that we can calculate a cross product and thereby find the area. This is a trick that your math teacher would be happy to share with you. We're also on the image drawing a box around the line and then putting a little red circle in the center of the image. And we're calculating the XY coordinates of the center of the April tag. So not only may we find the size, we can find the XY coordinates. And these details, the size and the XY coordinates, may be used to give feedback to the robot to help it center the image and thereby center its aim in shooting towards a target. We're writing to an output file, and you'll see all of this here in action now. So I have several images to process, and 4, in fact. I'll show them to you. The first one is actually called A1. So I'm just going to process file image A1 right now. It's this one, and it has a bunch of April tags. I will then go to some other April tags, and we'll see the results in these 4 file types. The first 3 are just random April tag files I found on the internet. It turns out, well, we'll see there's a difference. Not all 3 of them have the same results in processing. And then there's the 4th one that really highlights the importance of getting the right type of April tags. All right, so we will see now the program running for file name A1. It displayed here all of the X and Y coordinates of the A, B, C, D points representing the 4 corners of each of the April tags that it found. It found 40 of them in the image file, and then it's just displaying here for our reference. So it is in fact somehow working. Then we can look back here at what it did. It's processing this now. It looks like I'm having an error, is it? Oh, here's the processed file. It put a little green box around each of the images so it knows where it is, and it put a red dot in the center of each to know that it knows where the center is. And those are some very important details that you may use to send to your coprocessor. And in practice, you're probably only going to have 1 or 2 of these April tags in a camera image. These are just artificial examples. All right, so that's the first one, A1. I'm just going to process A2 and A3 and the other one in turn. So the second one, it processed them there. It found 12 April tags. And there it is. Oh, that didn't work so well the last time. It didn't find 12 of them. I don't know what happened. But for some reason, it did not draw the green. Oh, there is a fine dot. Oh, that's why it's so high resolution. It did draw a green border around each, and it did draw a dot. At first, I had thought it was the wrong format of April tag, but I didn't realize it's a rather big image of 2100 by 2800 pixels. So we can't see it from this magnitude or size. I have to zoom in. So there's the second one processed. And so there's a good discussion point. How big are your pictures? Processing a smaller image like this one is really different from processing such a big image, especially if you've got numerous images every second being processed. So you have to set your camera to the right resolution so that you're processing just enough information to be able to do it in a timely manner and extract the information as required. There we have A3 now. the third image being processed, and 80 April tags were found. And we see this one has a much smaller size. So you see here on such a small image, only 255 by 197, we can still find April tags. And that's why they are looking at April tags as a viable option, because even with a low resolution image, you can fairly reliably find these April tags and then identify where they are, just as what is happening here. The final one you'll see here, we have 6 April tags in 6 different formats. So at first you might expect it to find 6 of them, but we'll see tag formats is the name of the file. When we process, it found 1 April tag because only one of them is in the required format. And so zooming in there, we see the green box and the red dot. Only on the tag 36H11 tag, all the other tags were not found by the algorithm. So I hope this gives everyone a little bit of an overview of the vision system as it may stand in 2023. It will be a hybrid year where they're phasing out the retroreflective tape and then introducing the April tags, with any learning from this season being incorporated into the 2024 season, when they will turn to exclusively April tags, as far as I've gathered. So yes. And there's a great point, as Al has set out, that capturing in true grayscale will really pull down your processing requirements. That's another great thing that can be gained. These were indeed color images that carried a lot more image information. So capturing in grayscale to begin with would cut down your processing by a considerable amount, I would hazard to guess. I would really love to hear any comments from some of the teams that may have used April tags or the other vision systems, and any suggestions for future follow-up on this topic, as this is a rather new topic for our community.
Hey, William, I just put a post in the with a link there, but just saying they did switch to saying that they're going to use the 16H5 tags.
Oh, pardon?
First is going to use the 16H5 tags instead of the 36H11.
Oh, really? Did they just change that or something?
Yeah, 2 weeks ago, I think.
Oh, I missed that. I'm so sorry. Okay.
Yeah, so, like, honestly, I've only been looking at April tags for like a week or so, and I ran a sample script that I think close to the one you had that found those tags.
Yeah.
Looks like I couldn't figure out at least how to look for the other type of tag versus the 36H11. It seems like that one was more common, at least. So
Okay, so
an idea, maybe I gotta look into it, but that would probably help.
Might you just share with us, just for in the chat here, the actual name of the new tag, as I've missed that update?
Yep, I wrote it in there as tag 16H5.
Oh.
And then I threw a link to the actual blog from first.
It's interesting. I can't see it here in the text
I don't
chat.
see it in the chat either.
Yeah.
Oh, can't see it?
Nope. Yeah, so there's only 5 possible tags, but the pixel count is even lower. So I think they want to be able to, so we could capture it from further away.
Nice.
For some reason I only sent it to him, so.
Ah, here we are.
Here we go.
Thank you so much. Oh, I didn't get up to November 9th when I was processing this particular.
I'm not on Zoom that often, so I'm just still technical issues, I guess.
Oh, excellent. So they crossed that off and it's tag 16H5. So great. That's a interesting sort of thing. Because of the Python programming approach here, we could change that in that particular script. Just going back to the script there. Share the screen here for a moment again. To change the type of file with this script or the type of April tag, all we have to do is go to this options button. Or not options button, rather, the options method, I suppose. And we just type in the actual name we're looking for here. And so that really helps. This is general enough code that we could just change that parameter and search for the new type of April tag. So that's really appreciated. Thank you.
Yeah, so we've been messing around with photon vision. It's similar to what he's been showing. It runs on a Raspberry Pi. It's Linux based. It's all the same stuff. It's just it's like a fully developed solution. You don't need to do any programming on the Raspberry Pi side. You just need to like install the software, do a little bit of tuning, and make sure it's all hooked up to your robot and stuff. But of course, you still need to program it on the robot side. So, or on the RoboRio side, you need to develop the software to do whatever tracking you want to do. So that's a whole nother thing.
Yeah, each team may address it at the level that they're comfortable with, as there are varying numbers of team members available to work with this and mentors. So in some teams' cases, they do completely custom systems. Others in the last few years have really enjoyed the Limelights, although the Limelights are being phased out and are apparently in very short supply as well. It's from what I've heard. So that could be an issue.
Yeah, the Photon Vision software is very similar to Limelight software. The main difference being that it's an open source program that's being developed for just to work on any Raspberry Pi, really.
Nice. I think that's a really great solution, as it can be highly customized. It's a really great learning opportunity in that way.
And it'll run on the old Limelights too. So like in our case, we have a Limelight running Photon Vision.
Nice. So there's a really great tip from Samuel. The Photon Vision, is it available just at that website, or is there a particular link that would be best to search?
Yeah, they have a website. I'll put it in the chat here. Now, the April tag stuff is in beta right now, so I don't think you'll find that on the website, but anyone's explored Chief Delphi, it's all in there right now. So
meanwhile, Al has a really great question. And how bad processing will be if it's only done on the reel with no co-processing? Based on the conversation we've had so far, our best bet for making it work is to reduce the image size and keep them all in grayscale, and then keep a very simple program. The one question that's hard to answer is the overhead that's being taken by the Python program to process these images. And I'm only processing one image at a time, and it comes up with a fairly instant answer, but in the middle of a RoboRio, in the middle of a competition with a real-time robot that's prioritizing input from the driver station, that might be an issue. So yeah, that remains to be seen, I suppose, with teams doing experimentation. It would be great for us to share whatever data we can gather from that sort of experimentation process. It is possible to do a little bit of research as to how much a Python script running in the background will take up on a RoboRio and so on. So it would be really interesting to see how far the teams get into the idea of characterizing the performance of vision processing on either the coprocessor, the RoboRio, or even a driver station laptop. So we'd be very happy to take any additional questions. Oh, I see Al has a hand up here.
Yes, hopefully some people can answer this. So just as a general question as to how you would, or how people have applied this before, like one of the things that I'm hoping we can do this year is, I'm assuming these are going to be, if it is a pick and place type game, and you're going to try to drive to a target to pick up an object. Is that something where you are continuously scanning for images, or you're just, when you want to drive to target, you scan once, obtain image, set your path and drive to that and then maybe scan again 1 second later? Or is it a continuous scanning of images? Or how do people typically do that? Like, is the scanning of images and processing of images a continuous process, or is it just an on-demand?
I think it depends on if you're using a coprocessor, it's usually easier to just let it process the whole time. And then the network tables are the constant stream, and you just pick up those numbers when you want to pick them up. Typically for aiming where you want to go, you probably would just ask the question to your either the coprocessor or process on need, like you said. Like you would say, yeah, well, where is it? And you're off axis, so you turn towards it and then you start driving towards it, and eventually you'll probably want to do that again at a certain frequency just to error correct.
So I guess from people's experience, what can you get away with? I guess what's the
when we used to do like USB camera and vision processing on Rio, like we were targeting a lot. Now we weren't using swerve. I don't know how bad the math is on swerve, but it wasn't a problem. It was just harder to set up the pipelines and whatnot. So I went to Rio, to Limelight, I mean.
Yeah, our experience was like when we started doing vision, we'd figure out, okay, we're this far from the target, and then we'd never check our vision, our values again. We'd just spin up the shooter and shoot. But like later on this year, it was constantly changing the RPM of our shooter and a bunch of different things, all based on how far we were. So if in the middle of it spinning the shooter and getting ready to shoot, someone bumped a robot, it would take care of that and keep tracking the target and adjust as it needs. So it kind of, I don't know, depends how much work you want to put into it.
And the trick was definitely to decimate the image. So you ran the webcam at not too crazy a resolution, and as soon as you got that image, you flipped it to black and white. You shrunk the resolution down to the kind of lowest you needed, and then you did all your fancy processing. That speeds things up considerably. And Grip used to tell you how much it took to time, like how much time it took to process every stage of your pipeline, so you could get some idea of where the bulk of the effort was. And you could really see that if you started doing shape recognition before you went to black and white or did your thresholding in the case of reflective tape or whatever, that it was exponential growth. Whereas some other steps in the pipeline were like, you could optimize the heck out of them and they barely made a difference. So don't spend your time there, spend your time on some of the other steps.
I guess the concept is, if we have 200 pixels by 200 pixels, that's way less than 2000 by 2000, like we saw. And so that makes a huge difference if we can first get the image into the computer as a 200 by 200 in black and white. Wow, then that's going to go a long way to saving some of the most processing intensive steps.
Taking it a step further, I mean, this is like months of work, but you can get into full pose estimation, which figures out where your robot's located in relation to a vision target. You can use that to figure out where you are on the field, but that's a lot of work. Like if you haven't done vision, it's probably not a good first project.
Enthusiastic grade 12 calculus students would be able to do that in fun. Dear friends throughout the province, I unfortunately I have another meeting that I could not get out of, and it's starting very soon. I would be really happy to follow up with any questions, and I'm sure some of the mentors here would be happy to also field any questions about the vision processing. Meanwhile, I'll post any of the materials from this evening, and if any of you send things to me, I'd also be happy to include them in that post, and maybe send them in the next program update and put them on First Canada's YouTube channel. So, well, thank you very much again, mentors throughout the province. Looking forward to seeing all of you very soon at competitions here and there and everywhere, and hope you have a great season leading up to the kickoff. And see you next week for the next mentor call.
Thanks a lot.
Thank
Hopefully
you.
we can find some Raspberry Pis in the next year.
Sure. Hopefully.
If not, apparently we'll be cannibalizing our line lights. They have a
Oh, no.
Raspberry Pi in them. So
Oh, okay.
they run off
Thank you,
Raspberry
Bernard.
Pi, which is why you can put all these other things. It's just Linux.
Well, take care.
Industrial single board computer.
Mhm.